I'd like to take 3 minutes today to speak with you about diabetes. 3 minutes. That's only 180 seconds. And in that time, 9 people will lose a limb to diabetes. Because somewhere, every 20 seconds, a limb is amputated as a direct result of a diabetic healing complication. And I don't think it will take any more than these 3 minutes and those 9 limbs lost for us all to agree how important it is that we do whatever we can to understand what goes wrong in diabetic healing and what we can do to help. When you are wounded, the healing of that wound relies on a large number of different types of cells in your skin to carry out their own important roles, together, in time, and in harmony. And if even one of those roles is not carried out, then the healing of that wound can be delayed, or it might not happen at all, which is what we often see in diabetic wounds. In this sense, you can think of all those different types of cells that make up your skin as a team of individual players, all working together towards one end goal. And if a player is missing, or they're not doing their job, then that end goal of healing might not be achieved. In the skin of patients with diabetes, there is a documented loss of one particular cell type. There's a player missing, and that player is called the parasite. The effect of this parasite loss on diabetic healing is not yet understood, but we do know that under normal, healthy circumstances, these cells help to build blood vessels and to regulate the inflammatory response that your body sends to combat infection. We also know that both of those important processes can be compromised in diabetes. Diabetic skin is slow to rebuild lost or damaged blood vessels, and the inflammatory response is often heightened and prolonged in a way that doesn't allow that team of cells in the skin to carry out their healing roles. In my PhD project, I'm investigating the link between parasite loss and all the things that go wrong in diabetic healing. I want to understand the mechanisms that control the behaviour of this cell type and just how important this particular player is to the team. I found that in wounds with less parasites, there is indeed slow regeneration of blood vessels and an uncontrolled inflammatory response. I've also found that if I decrease the expression of a particular protein, I can restore the number of parasites present in a diabetic wound, and in doing so also restore positive healing outcomes that had been lost as a result of diabetes. As a part of my own team, my research team, I'm working to understand how these cells function so that we can begin to develop therapies which either target parasites to enhance their function or therapies which deliver extra parasites, extra players, to that team of cells tasked with the healing of diabetic wounds. And hopefully one day, as we find new ways to encourage better diabetic healing, each 3 minutes that we spend speaking about this will no longer mark the loss of 9 more limbs.